Going to start, okay? Here we go. Okay. Good morning. Good morning, everyone. Welcome to the first lecture of the human-machine interaction. Those of you, I think I've taught most of you the first year. Those who don't know me, my name is Hani Alair, and I am one of the teachers here in software engineering. That will be teaching you the human-machine interaction course, basically how you will design. Come in. Close the door behind you. Thank you very much. How to design an interactive system, and most importantly, how to evaluate an interactive system. And you will have to do that during this block 6 of your software engineering education. The entire human-machine interaction course is given in English, so English is the official language. The lectures will be in English, and the reports that you submit will be in English. If you are going to give a presentation, it will be in English. It's part of the internationalization effort that the Haagse Hogeschool is trying to do to make each one of you, what do they call it, a world citizen, so that you can function anywhere in the world after you graduate from here. All the lectures are being recorded. So this lecture is also being recorded right now, and the recordings will be on Blackboard. So if there's something you don't understand, you can later on view the recordings on the Blackboard and go over it to review parts that you didn't understand. So also when you're preparing for your experiments, it's very nice to go over the parts that you don't remember very well. If you're writing your report, it's also nice to go over the parts where I explain what to write in each part of the report, so that you are going to remember exactly what you need to do. So I don't expect you to go home and then rewatch all the lectures again, but it's a nice kind of additional tool to help you if you need to remember something. Okay. In the beginning, I have some pictures from last year. So these are some of the students, second-year students from last year, presenting their ideas to a panel of, these are company experts that were evaluating the ideas. And this is a Reen from the diff. And here you can see one of the prototypes that the students made. They actually made a 3D print of the device that they made. Inside there was a Raspberry Pi and some extra electronics that they printed the housing where they could put it. And immediately you can see that the experts start playing with the device because it's actually something that they can touch, which is something that has much more value than just like a concept or a drawing that you have on the screen. So I would also recommend, we'll also talk today about some rapid prototyping techniques where you can make very quickly and easily something that you can hold in your hands that represent your product. More photos of students presenting. That's me right there. Also, we had a panel of the lecturers evaluating the pitches. This is the plan for this course, so the human-machine interaction course, and you guys are, of course, now in here. So these are the week numbers, and these are the lectures that you are going to take. We are today going to have a quick introduction about human-machine interaction, and we will also have a second lecture talking about the rapid prototyping techniques where you can make the a prototype of your device. So we have a lot of material to cover today. So try to wake up and keep up. Okay, next week we will talk more about how to make measurement questions for the experiment that you're going to conduct on the system you're building. We're going to have also a little test experiment, very quick, just to warm you guys up. After that, we're going to plan meetings. So each one of you in week 4 will plan meetings with me, so we can look over your plans, what questions you're going to ask, and then try to improve the quality. Then we'll have more lectures about preparing your usability study, about writing the report, analyzing the results, and in week 8, you're going to present your work, and we're going to give you the grades. There are important dates in the middle. So 17th of December, I expect you to submit a plan. So basically, it will be a plan of the experiment that you're going to do, where you will explain exactly what are the steps of the experiment. More information on that later. And this is necessary so that I can also give you feedback about, okay, I think this will be a problem. You will need to do this before that, etc., etc. So it will also be helpful for you to prepare better for your experiment. And 14th of January, so a few days before the final presentation. 14th of January is the final presentation. 11th of January, a few days before the final presentation, you'll also submit your final report so that I also have some time to read it before you guys present your final presentation. So these are the important dates. So you guys also have the big picture. And if you're ever in doubt, like what are we going to do now, just look back at this slide, and then you will have a reminder of where you are in the big plan. Any questions so far? Good. Let's see. So how the course is set up, there will be the lectures to discuss the theory, to give you guys examples, and to have discussions. I also expect you guys to ask questions during the lectures. We have some practical lectures, like next lecture, we are also going to have an experiment where you guys are going to do some quick usability experiments, and you're going to present your results. So there will be more interaction. And in there, you're expected to work as a team. So for these lectures, I expect everybody to be present, because if you're not, then the other members of the team will have a problem. Because you're already divided in groups, right? Yeah, all right. And you will earn your final grade with both the final report and the presentation. So you'll do the experiment, of course, the experiment has to be good. You will write it in a report, and you will present your results, and the presentation and the report combined will make your final result. Okay, that's it about the course and how it's set up. Now let's go into good design, into design. So what is good design? Good design, when it's done well, becomes invisible. It's only when it's done poorly that we notice it. Okay, what does that mean? So we go more in details. We only notice it when it's too hot or too cold. Yet if it's perfect, nobody says anything. So this is what you experience about climate. If everything is perfect, then you think like everything is fine. But when it's too hot or too cold, then you think like, okay, something is wrong here. and then people start complaining about the temperature. And it's also the same thing with design. If you have a smartphone, and a smartphone, you interact with it by touching the screen, and now all the smartphones look like this, then everybody thinks that, well, this is just the common sense, you know? Of course, it's a screen, and then you touch it, and then you interact with the phone. And nobody has a patent on this because this is an obvious thing to do. But until the first iPhone was designed and produced, people were arguing that, no, you actually need the buttons because the buttons give you added value. You need the tactile feedback. This is what everybody would say. The first Android phone, its selling point was that it had a physical keyboard that you can fold out. And BlackBerry had a physical keyboard, which was also, it's like their main thing. And their commercials actually stress that, oh, I can always type faster with a physical keyboard because this is what I'm used to. But then slowly but surely, everybody started noticing that typing on the screen is much faster than actually pressing physical buttons. And now all smartphones look like this. So it seems to be common sense, but until we figure it out, until designers can actually make something that is correct, we have to struggle to find our way to reach that point. And the work that we are going to do here, the things that you're going to learn here, will help you go into that direction faster. Making usability studies, talking to your end users, making evaluations with them, and starting to understand how users actually use your devices, your systems that you design, will help you go through this process much faster. So if we look around, we can see examples of bad design everywhere. And then it's really obvious for us, right? So bad design is really easy to spot. But trying to find good design is more tricky. So here we have the staircase of death, where you cannot find where you have to step. And here we have designers that cannot see a little bit further in the future. But it's a good evaluation of their design right there. So wouldn't it be nice to have some kind of a checklist, things that you need to check in order to get a design to be really good? Well, there are plenty of checklists that you can go through. One of these checklists is given by this German designer that worked at Braun for a long time, Dieter Rams. And he had 10 rules of good design. And if we go through them very quickly, number one, good design has to be innovative. So this is the innovation entrepreneurship block. So this is kind of fitting. And you would think that it's obvious that you need innovation in order to come up with new things. But here we have a quote. Some guy said at some point that everything that can be invented has already been invented. Everything has been invented. Nothing new is ever going to come to the world. And this statement was given by Charles Dell, the commissioner of the US Patent Office in 1899. So a few hundred years ago, the commissioner of the Patent Office said that everything that can be invented has already been invented. This is obviously very wrong because there are new technologies being discovered, developed, found every day. And it's the job of the designers, the designers, engineers. It's your job, basically, once you graduate, to use these new technologies to come up with new systems. And today, especially, there is so many new technological revolutions. Like we have all these technologies, all these sensors in our pockets And we are scratching the surface and utilizing these technologies into doing something with them. So you guys have like a huge potential to make new things in order with the potential of technology that's available for you. Let's see. So good design makes a product useful, and you would think that this is obvious, but actually, one of the famous researchers, experts about usability engineering, has Donald Norman wrote a book, and in that book he says that there are 3 reasons why we actually buy products, and that products can be designed to be, let's see, visceral, behavior, or reflective. Visceral is a fancy word to say that it's just because it looks beautiful. So you can just buy a piece of furniture that looks really, really nice, and you just want to look at it. And behavioral means it's useful, so you can use it to do something. Or it can be reflective, which means that it makes you think. And an example of that is this teapot on the cover that is impossible to use because the spout is from the same direction as the handle. So in order to use it, you might burn yourself. So this thing is useless, but when you look at it, it makes you think. So this may be a nice thing to look at, but if you think about its utility, if you think about its usability, then of course it's badly designed because you cannot use it to make tea. Okay, good design is aesthetic, which means that it looks good. So here we have a very designed juicer where you can you put the piece of fruit on the top and the juice comes to the bottom, and you see that the legs of the juicer are angled upwards so that the juice cannot go down the legs of the juicer, and all the juice comes down at the center of the juicer that goes down to your cup. So it's actually, it looks really nice, and it actually works. It actually does work because I have it at home and I actually use it, and it does work. So it's and we can all agree that this looks more designed than, or better designed than an ordinary juicer. You disagree? Sorry? Good design makes a product understandable. And to explain this, I use an example of this remote control from the 70s. Back then, it was, everything looked like this. Everything had identical buttons. They felt identical. They looked identical. If you hold it in your hand, you don't know if it's the right side up or upside down because it's just a square with little squares inside it. But if you look at remotes that are designed now, you see that they are designed to fit in your hand. Sorry? You see that they're designed to fit in your hand. Each button looks completely different, so you can feel your way through the buttons. You know what you are going to click on without even looking at your remote. It's really impossible to hold this remote upside down in your hand and not notice it. So you see that the product, in its design, it's inherently more usable than products that came before. Another example is this door, where you, just by walking to the door, the way that the handles are shaped, where you need to push, there's only just one big button, so you know that you need to push it. And where you need to pull, there's the handle, so you can grab it and pull it. So the door itself, in its design, it already tells you how to use it. You don't need a manual or need to read like push or pull. Let's see. So good design is unobtrusive. You see that an example of a kind of a design that gets in your way to do things is this remote. This remote is fully functional, so you can actually use it to operate your device, but you can see that if you actually try to use it, it kind of gets in your way. And an example I also mention always is Linux. So Linux I try to use as my daily operating system for a long time. And technically you could do everything with Linux, and you could compile all the drivers to get all your peripherals to work. And maybe today Linux is much easier to use. But back then, although Linux could do everything, it was just difficult enough to always be in my way to try to do things. So I tried to switch to Linux for like 5 years and it never worked. And then I tried Mac OS, and then I switched to Mac OS within 1 month without even planning. The first Mac I bought, I was planning to install Windows on because that's what I was used to. I knew it was difficult to switch to another operating system, but just because it was easy, then it kind of happened organically. Another example is this Dell all-in-one computer. You see that there is an interface on the screen, and the interface, if you're just using the computer, the interface fades out, but it has a proximity sensor. And when you reach to the buttons on the screen, then the interface senses your hand, it lights up, showing you the functionality of each button. And even on the speaker, behind the speaker, there is a slot for the CD drive, back then when there were CD drives. And it will show you an indication also if there is a CD inside the CD drive or not. So this is also like a design that goes out of the way when you don't need it, but then when you actually do need it, it will help you use the system. Let's see. Good design is honest, so it doesn't claim things that it can do, that it is not able to do. And the example I always mention for this is the Wii U TV. Anyone familiar with that? TV.
Oh, okay.
Yeah. So when the Wii U first came out, Nintendo claimed that the Wii U will be your entertainment hub center for your home. And then all your TV will flow through your Wii U. And on the screen of the Wii U, you can already see all your programs, all your device, all the programs, all the shows, all the schedules. And then you can like basically run your whole TV entertainment through your Wii U. And probably the reason you never heard of it because it was never actually released for Europe. It was released in the US for a while, in US and Japan in 2012, and didn't really work that well, and it was discontinued in 2015. So it was what they would call half-baked. It was claimed to be one of the main selling functionalities of the Wii U, although they didn't actually finish this functionality, and it wasn't even designed well because it didn't work, and it was canceled. And eventually the Wii U failed. So it's kind of doesn't really work well when you step outside of what you can actually offer to your users. Good design is long-lasting. An example for that is this Barcelona chair that I like. And anyone has any idea when this thing was designed?
You want a year?
Yeah, like before the 2000s. Who thinks it's after 2000? Before would be likely. So before the 80s, 70s. Yeah. So it kind of looks a little bit modern, but maybe not too modern. But it looks nice, right? So this thing was designed in 1929, and the design is so timeless that it's actually still being manufactured and sold right now. So this is considered a classic designer piece. So this is a classic design. Modern design has, what do you call it? Well, they're designed to be outdated. So obsolescence. Sorry? Planned obsolescence. Thank you very much. So there's planned obsolescence in these devices, and we cannot be too harsh on these devices because these devices no longer function independently. They function within an ecosystem. So it is also very hard to keep a device running for a long amount of time, because then you will need all this. You need the App Store and the apps and the software and the Wi-Fi protocols and the Bluetooth protocols, all to remain compatible with the device in order to keep it running for a long time. And that's why, because it's so complicated right now, there is designed, what do you call it? Obsolescence. Planned obsolescence, where, okay, we can maintain all this infrastructure around this device for like 5 years, but after that, no promises. If it lasts longer than that, it's okay. I added this XS Plus yesterday. I don't have place for the XR, and next year probably I'll need to have a different slide because then I don't have any room for new phones. Good design is thorough down to the last detail. And an example I have for this one is the indicator LED on older Mac models. And you can see that these LEDs are invisible when they are not on, because in order to make them, Apple bought a special laser that can make invisible holes in the aluminum chassis, and you will only see the light that shines behind these holes if it's turned on. But if it's turned off, then the holes are so small that you actually cannot see the hole for the LED indicator at all. And in typical Apple fashion, they actually bought all the lasers that could do this so that they would be the only company that can have this feature on their devices. Good design is environmentally friendly. An example for that is the Hammer 2. So the Hammer 2 is, it was on Top Gear. I saw it. Clarkson was reviewing it. He said it was cool. He said it was, he felt really manly when he was driving it. But let's see. It made the Times list of 50 worst cars of all time because it was so terrible to drive, and it was very environmentally friendly. So it was environmentally unfriendly. You have a question? No. Okay. And let's see. Good design is as little design as possible. Now this sounds a little bit strange, but what's meant here is that this would be a typical remote that you would use on a TV for in 2016. But then a good example of a remote that is very designed is the Apple remote that you would use to. This was used before to drive your Apple TV device. And then all the functionality in the Apple TV, you could operate with only 6 buttons. So there were 6 buttons on the remote, and it could distinguish between a quick press and a long press. So if you hold it, the button will have a different functionality. But with only 6 buttons, you could use all the functionality on the device. And this seems to be very simple design, but actually to make this design work, the software, so the operating system, has to be so well designed that you can reach all the functionality with only 6 buttons. And it is an incredible engineering challenge on the software developers, which they managed to do. The second model of the Apple remote already went a little bit bad because they added a 7th button that actually had the same functionality as the main button. So this part was still pressable. And then of 6 buttons, they added a 7th button, which didn't have any extra functionality. And I still don't know why they added it. And then the next generation of the Apple remote.
Oh, that's so horrible.
Yes, that's the horrible one, exactly. They made this remote, and then this remote, it also had to work as a trackpad that is clickable. You also had to use it to control Siri, so it had a built-in remote control. You could use it as a controller for the games that are built into the Apple TV, and they crammed in all this extra functionality that no one actually really asked for, just to increase the functionality of the Apple TV. And it was so badly designed that we actually, if you look at it, it's completely symmetrical. So the buttons are almost identical. Instead of this design, where you could actually feel the buttons in your hand, and you see this is a navigation and there's a menu button. Here, all the buttons look the same. And here there is an empty area, and here there's an empty area. So a lot of people complained that, yeah, they don't know if it's the right side in their hand or not. And then, although Apple didn't say anything, they very quietly changed the design and added a hard circle around the menu button, so you could feel that it is the right side in your hand. Now, what does this tell us? What does this tell us, that they added this circle to the remote?
So they came back to a poorly designed remote and made it a little better. Like,
yes,
yeah, we fucked up.
It's a patch. It's a patch. So they are kind of admitting that they did something wrong. It wasn't working. And this is kind of a quick fix. They don't want to redesign the whole thing. It's a quick fix to make it a little bit better. But the design of the thing is inherently inadequate, because the thing is just, it doesn't give you the same ease of use as the original remote. And they cannot just throw away all the extra functionality in the Apple TV because it's you already paid for it. It's already built into the thing. So they just added this quick fix and just like, okay, let's just get this thing out and move on with our lives. Okay. So these are the rules. And now you know all the rules. So now you know how to design a successful product. Actually, no. Unfortunately, it's just a start. There is this list. There are other lists that gives you a lot of advice about design checklists that you say, okay, if you go through these checks, then your product is usable. But there are always things that you cannot predict when you're designing. Okay, when you are first planning things out, there are things that you cannot predict because people work in mysterious ways. They don't really follow what you want them to do. They do what they want to do, whatever is easier for them, whatever they're used to doing. And it's really difficult to force them to do that. But then when they do things their own way, then your device, your system doesn't work the way you want it to work. So if they do this, then the grass doesn't grow in this area. So it actually breaks the vision of the designer that designed this path. Users work in mysterious ways. They will not use the device the way that they are supposed to use it. But as a designer, we need to understand how the users use the device, and we need to make it in a way that is also good for the end users. Okay, now I know that what's going through your minds right now. You would think that, hey, I'm a smart guy or girl or lady, or I'm a smart person. I will be able to do it better. I know what people want, and I will not fall in this trap. But this is a common mistake, a common misconception. You always think that it will not happen to you, but it happens to the best of us. And it happens even to Apple. So Apple is like a big company. It's one of the biggest companies in the world. And they had the antenna gate. Anybody knows what antenna gate is? Yeah,
Wrong.
they're holding it. Okay. So antenna gate, I think when the iPhone 4 was released, if you held it in a particular way, then the reception of the signal reception of the phone will keep dropping down until it goes to almost zero. And I had an iPhone 4 and I held it like this and it did drop down. It's actually true. It drops down until it's zero. Yeah, you also had one? Yeah. And people started complaining. And then, very famously, Steve Jobs himself replied to one of the people who complained about this problem. And Steve Jobs says, just avoid holding it that way. Why are you holding your phone that way? That's the problem. The problem is the way you're holding it, not the phone, of course. Okay, so that was a very stupid comment from Steve Jobs, because you see him in the keynote presenting the iPhone 4, and he's holding the phone the same way. So if a company like Apple can fall into this trap, then it's also very likely that you may also fall into the same problem. So you have to be, in order to see these problems, in order to visualize them, to bring them out to the light, you have to do the usability studies, which you will learn how to do in this course. To bring it to a more serious note, to show how important usability studies are, this is an airplane crash in 1989 where 47 people died. It was really tragic because the plane had problems and the pilot and the co-pilot were trying to fix it, and they went to the nearest landing runway, and they almost made it. It was less than 100 meters away, but the airplane finally crashed meters away from the runway, and so many people died. And they eventually found out that one of the engines had a problem and the other engine was okay. And the pilot and the co-pilot noticed this. They checked their instruments, and tragically, instead of turning off the engine that had the problem, they kept that engine on and turned off the engine that was perfectly okay. And if you look at the instrument panel that the pilot and the co-pilot were looking at, this was the panel from the old airplane, but they were actually flying a very new model, so the 737-400, which had a digital display that was a little bit different. And the indicator that shows the engine vibration, it looked like this in the older panel, and this is how it looked in the new panel. And if we zoom in a little bit, you see that here we have a huge dial in the middle pointing at the number that shows you the vibration reading. And here we have these little LEDs that are very short on the outside of the dial. So it's not something that is traditional, intuitive. It's like this new design to indicate where the amount of vibration in the engine. And just looking at it in the middle of a disaster situation, the pilots couldn't immediately notice which engine had the vibration, and they switched off the wrong engine. So this is a very, very tragic example of how to have very good design, very intuitive, very easy to read, easy to use, can save lives, can be very, very important. Of course, there were other variables at play here, but I think just they actually looked at it, they checked the instruments, turned off the engine, they turned off the wrong engine. So I think this is, for me personally, it's one of the main reasons of the disaster. Okay, so what are we trying to do here? Donald Norman explains it this way. Donald Norman is the guy with the teapot from the other side. He explains the way design works is that we have this designer over here, so that's you guys, and then we have the user. And in the designer's brain, there is this design model. And the designer has this model in his brain, or in their brain, his or hers. The designer has the model in their brain, and then they kind of make the system, and they put the design in the system, and then here you go, this is my system. They give it to the user. Then the user interacts with the system, and then they make their own model according to their understanding of the system. Maybe they read the manual, maybe they don't read the manual, maybe they just play with the system and say, oh, whenever I press this, this happens. So this is the way to make this functionality happen. And most of the time, the model that the user creates in their brain is not exactly the same as the model that the designer has. So the designer has this vision about how their system should be used, and the user kind of has a different understanding based on their interaction with the system. And the designer doesn't know, of course, what the user is going to know. Because you design your own system, you know exactly every functionality in the system, and you expect that the user will do it. So anytime you try it, you know exactly how to do everything. And it seems to you that it works fine. But then the user gets it, and then they are using it, and they say, oh, it's not working. This thing is broken. The times that my parents told me that their computer is broken, it's amazing, because just because they don't exactly have to do a specific thing. So we have the designer, we have the user, and then there's this wall between them, because the designer doesn't talk to the user and don't know what the user thinks. But if we break this wall, if we start talking to the end users, then we start to understand where the problems are. And this is what you actually do when you do usability testing. When you're doing usability testing, you try your system with some end users, and then you see what they understand of your system. And that's the whole point of what we're going to do. So if we look at the cycle, you kind of make an analysis of what the users want, and then you use that to design some kind of a system. After you design the system, you make a prototype, and the prototype, you use it to make some usability testing. And then if it's not good, you will design it again, you make another prototype, and you do some usability testing, and you keep going through this cycle until at some point it is good, and then you will go to end product and start trying to sell your product. And then if your system has some more life in it, you will again evaluate your end product and then start working again in this cycle, developing the second model of your product. So what are the characteristics of a usability test? So we are going to work here. The whole point of this course is to help you conduct a usability test. What is a usability test? The goal of the usability test is to improve the usability of a product. With each test focusing on specific goals. This is very important. Each test, only when you have the final product, you can test everything. But if you don't have the final product, you cannot test everything, because you're making prototypes and the prototypes are not complete. So each prototype is used to test specific things. And this will be very important when we are talking about prototypes in the second hour today, and when we are talking about the experiments that you're going to do. The specific goals that you're going to try to test in your experiments. The participants in your test represent the real users. So if you're using it, your product with 60-year-old people, and you're testing it on your classmates here, then they don't represent the real users, because it's different age group, different experience with technology, etc., etc. The participants do real tasks. So you give them like some list of tasks that are similar to what they will do in the real world with your device. You observe and record what the participants do and say. So you keep notes. Okay, it took them 5 tries to actually open their email. So probably this is not working very well. They're saying, hey, this sucks. This is also a good indication that this is not going very well. So you keep track of this for all participants. You do it with 10 participants, and then you collect some data. And then you analyze the data that you have collected, diagnose the real problems, and recommend some changes to fix these problems in the future. Okay? And number 4 is really important because, as we all know, this works.
Remember, kids, the only difference between screwing around and science is writing it down.
Writing it down. So you're going to do these experiments, you're going to have lots of fun, but then to make it into science, you write it down, then you analyze the data, and then you make some conclusions about that. That's Adam Savage from Mythbusters. Okay, so this is the first lecture. Any questions so far? Come on, one question. Okay, we have 15-minute break, and then we are going to talk about making prototypes of your systems. So we come here again at 11:45.